Hi everyone, this is Ravi Shankar from Department of Civil Engineering in Nanda Engineering College. In this video, we are going to learn how to calculate the ingredients for M25 grade of concrete by using a IS codal provisions. First thing, we have to finalize which grade of concrete is going to be used in our structures. So here I am consider M25 grade is going to use in our structures. So if you want to calculate the concrete ingredients means the first thing is cement. Okay, so we have to finalize which grade of cement we are going to use. Okay, because there are n number of types of cements are available like OPC, PPC, like that. Okay, in that OPC there is a 33 grade, 43 grade, and 53 grades are available. So here I am taking as a OPC 43 grade of cement is our construction purpose. And also the maximum size of aggregate I am considering as a 20 mm. And the exposure of concrete, okay, whether the concrete is exposed to severe condition, moderate condition, mild condition. So here I am considered as a moderate is our exposure conditions of our concrete. Okay, and also 100 mm slump I am going to consider because the workability conditions here I am considered as a 100 mm slump. Okay, and the reference code is here I am going to use two IS codal provision, which one is IS 456 2000 and also IS 10262 to 2019. Previously, it is in the range of IS 10262 to 2009. Now it is revised in 2019. So I am going to use IS 10262 to 2019. And the mode of complexing is needle vibrator. Okay, why we are going to use needle vibrator is to avoid the honeycombing. Okay, and also the fine aggregate zone is a zone 2. Okay, these are all the basic things we have to finalize before we are going to proceed for the calculation of ingredients for the concrete mix design. Okay, the test data of materials. These are 4 test data are necessary. Okay, before proceeding further. Okay, first one is a specific gravity of cement, specific gravity of coarse aggregate, and specific gravity of fine aggregate, and finally specific gravity of water. So here I am consider in my calculation, I am going to consider specific gravity of cement is 3.14 and the specific gravity of coarse aggregate is 2.62, specific gravity of fine aggregate is 2.72 and the specific gravity of water is 1. Okay, these are all the test data available in my calculations. Next, these are all the steps which are going to be involved in our calculation. First one is a target strength for neck proportioning. Second one is a selection of water cement ratio. Third one is a selection of water content. Fourth one is a selection of cement. And fifth one is the estimation of volume of aggregate proportion. And sixth one is the estimation of mixed ingredients. These are all the 6 steps we are going to follow. Okay. The first step we are going to be calculate is target strength for mixed proportioning. That means FCK dash. Okay, the FCK dash is a target mean strength. Okay, how we are going to calculate this target mean strength means in IS 10262 2019, they are giving the formula FCK dash equal to FCK plus 1.65 into S or FCK plus X. Okay, why we are giving they are giving the two formulas? We are going to consider the maximum value. So first we are going to calculate FCK plus 1.65 into S. S is a standard deviation. The standard deviation value is available in our IS 1026/2019 code book, table number 2. And similarly, for this calculation, FCK plus X is available in the table 1 of IS 10262/2019. Okay, so here we are considering as a M25 is our grade of concrete. If it is M25 means in the table 2 for M25, M20 and M25 grade, they are giving the standard deviation value of 4. So we are going to use the 4 is our S value. So 25 is our concrete grade. So 25 plus 1.65 into 4, we get the value of 31.60 Newton per mm square. Or else, if it is FCK plus X means X value is going to be calculated similarly from table 1 value. X is for M20 and M25 grade, it is a value is 5.5. They are giving the value of 5.5. So it is going to be incorporated. So 25 plus 5.5, we get the value of 30.5 Newton per mm square. We are getting the two FCK dash. First one is 31.6 Newton per mm square and another one is 30.5 Newton per mm square. Okay, so we are going to use the highest value adapter. We are going to use the highest value. So our target mean strength for this calculation is 31.6. Okay. So further calculation, we are going to use the FCK dash is a 31.6 Newton per mm square. Okay. Next, step number two. Step number two is a selection of water cement ratio. Okay, selection of water cement ratio. How we are going to get the selection of water cement ratio? Mean from figure 1 of IS 1026 to 2019. Okay, from figure 1 is available in our code book IS 1026 to 2019. Okay, there is a three curves are there. First one is a curve 1, curve 2, and curve 3. Okay, how we get this room means depending upon the grade of cement. Okay, if it is that the grade of cement means we are going to use the curve number 1. If it is a 43 grade of cement means it is a curve number 2. If it is a 53 grade of cement means we are going to use the curve number 3. Okay, in our calculation our grade of cement is OPC 43, so we are going to use the curve number 2, that is the middle curve. Okay, depending upon the curve, okay, we are going to get the water cement ratio. Okay, in x-axis they are giving the free water cement ratio, so we can get the water cement ratio from x. Okay, for this calculation we are in need of y-axis. Okay, the y-axis is 28 days compressed strength of concrete. Okay, here we are going to use the 31.6 Newton per mm square is our 28 days of strength of concrete, because it 31.6 Newton per mm square is our target strength for calculation. Okay, so from figure 1 of IS 10262, okay, the water cement ratio is we are going to get from, if it is a 31.6 like this means we have to consider this imaginary line. Okay, it is intercept in this point. Okay, we have to draw the vertical lines. It is intersect in the 0.47, so we are considering this is a 0.47 is for our water cement ratio from figure 1 of IS 1026 to 2019. Okay, but we have to check whether our water cement ratio is correct or not. Okay, how we can get the correct value means we have to consider table 5 from IS 456 2000. Okay, from table 5 IS 456 2000. Okay, they are giving the value of minimum cement content and maximum free water cement ratio and minimum grade of concrete for reinforced concrete as well as the plain concrete. Okay, here I'm going to consider as our concrete purpose is reinforced cement concrete. If it is plain concrete means we are going to consider this value. Okay, and also here we have to consider the exposure value. Okay, mild, moderate, severe, very severe, and extreme. Okay, in this calculation I considered my grade of exposure condition is a moderate. Okay, if it is moderate and reinforced cement concrete means, okay, the minimum cement content is 300 kg, maximum free water cement ratio is 0.5. This is the maximum water cement ratio, but we can get the 0.47. So this is a maximum value, but we are getting the 0.47. It is less than the maximum value. So the moderate exposure from table 5 was IS 456 2000, the maximum water cement ratio is 0.5 for moderate exposure conditions. Okay, but we get the value is 0.47. It is less than that value. Okay, directly we can adopt 0.47 or 0.45, but here I am going to adopt a 0.45 is a water cement ratio. Why I am going to use the 0.45 is a water cement ratio means depending upon the experience. Okay, if it is 0.47 means we are going to use the excess water. Okay, if it is 0.45 means we can reduce the water. Okay, if as much as you can reduce the water means we can get the higher strength. Okay, for example, if it is just to consider, okay, you are going to be calculate M30, M35 and M40, M50 like that means, okay, the water cement is we are going to use the lesser water. If you are using lesser water means we can get the higher strength. Okay, so here I am adopted as a water cement ratio is 0.45 in my calculations. This is a step number 2 value. Next, step number 3. Step number 3 is the selection of water content. Okay, for calculation of water content, okay, again we are using an IS 1026 to 19 table number 4. Here I am giving the table number 4. Okay, in this table, okay, they are giving the water content for various grade of concrete. Okay, if it is nominal size of maximum size of aggregate is 10 mm means the free water content is 208 kg. If it is 20 mm means 186 kg. If it is 40 mm aggregate we are going to use means we are going to use the 165 is a our water content. In this calculation, I considered a 20 mm aggregate for our calculation. So we get the value of 186 for 20 mm aggregate. This is a 186 value. Okay, but we have to consider another one thing is this 186 liters only alone for 100 mm sump value. But here I am consider the 100 mm slump value. Okay, but the value is applicable for only 50 mm slump. This value is only applicable for 50 mm slump. Okay, so the desired slump value for workability 100 mm slump. Okay, but our value is as per table we get the 186 liter 186 kg for 50 mm slump. Okay, so we have to increase our water content. Okay, for every 25 mm of slump value added, okay, we have to add another 3% of water. Okay, these are all the as per the codal provision of IS 102/2019 class 5.3. Okay, in class 5.3 they are giving for every 25 mm of slump is increased mean we have to add another 3%. Okay, so as per our desired slump value is 100 mm. Okay, so we have to add 6% as per codal provisions. Okay, so 186 plus 6% of 186. So we get the value of 197.16 kg per meter cube for 100 mm slump. This is our calculated value. Okay, but we have to reduce the water content. Okay, if we reduce the water content means we can get the higher strength. As much we can reduce the water content means we can get the higher strength. So as per as supervisor is reduced by using supervisor, we are going to be reduce the water content of 19% by using a trial and error method. Okay, so here I am considering as 19% of water reduction. So if it is reduced water content means 90% reduced means the final estimated water content is 159.7 kg per meter cube. Okay, how we get this value means 197.16 minus 19% of 197.16. So we get the estimated water content of 159.7 kg per meter cube. So this is our final estimated water content value. By using this value only, we are going to be calculate our cement content. Okay. So from step 3, we get the value of water content is 159.7 kg per meter cube. Okay. So the water cement ratio from step 2 is 0.45. From step 3, water content is 159.7 kg. Okay, so we are going to calculate the cement content. How we are going to be calculate cement content means there is a formula. It is water content divided by water cement ratio. Our water content is 159.7 kg. Okay, divided by 0.45 means we get the value of 355 kg per meter cube. Okay, so here we have to check. Okay, whether our calculated cement content is correct or wrong. So again we are going to use the table 5 of IS 456/2000. Okay, from IS 456/2000 table number 5, the minimum cement content is 300 kg for moderate exposure. Okay, this is called minimum cement content. You have to consider this is the minimum cement content. So our calculated cement content should be higher than the minimum cement content. Okay, so here what is our calculated cement content is our calculated cement content is 355 kg per meter cube. So it is always greater than the 300 kg per meter cube. So our calculation is correct. Okay, this is the step number 4. So final cement content is 355 kg per meter cube. Okay, next step number 5, we are going to be calculate estimation of volume of aggregate proportions. Okay, we are going to calculate the total volume of aggregate proportions. Okay, here we are going to be calculate depending upon the IS 456, sorry, by using table number 5 of IS 1026/2019. Okay, from this table 5, IS 1026/2019. Okay, for normal size of aggregate is if it is 10, 20, 40. Okay, if it is 10 and also there are zone 4, 3, 2, 1. Okay, likewise we are using 10, 20, 40. Okay, in our calculation we are going to use a 20 mm is our normal maximum size of aggregate and we are going to use the fine aggregate zone is a zone 2. So if it is a zone 2 and 20 mm means our volume of aggregate proportion is, that means volume of coarse aggregate proportion is 0.62. So this variable only applicable for from class IS 10262/2019 class 5.5.1. Okay, this table is applicable only for the water cement ratio of 0.5. Okay, this table is applicable only the water cement ratio is 0.5. Okay, but our water cement ratio is 0.45. So if it is 0.45 means we have to do some changes. Okay, here from class 5.5.1 of IS 10262 2019, every 0.05 mm of water cement ratio increase or decrease means we have to increase or decrease the volume of pore segregate from 0.0. Okay, so if it is 0.5 means our core segregate content is 0.62. If it is 0.45 means here the water cement ratio is reducing 0.45. If it is reduced means we have to increase the core segregate content. If it is reduced means here the value is applicable for 0.45, but our water cement ratio is this value is applicable for only for 0.5. Our water cement ratio is 0.45. So we have to change the volume of pore segregate. Okay, if the value is reduced means, if the water cement ratio is reduced means, okay, we have to increase the pore segregate. So here 0.05 is decreasing. So we have to increase the pore segregate, which means 0.45. For 0.45 water cement ratio, the volume of pore segregate is 0.63. We get the value of 0.63. So we can get the volume of fine aggregate. How we can get the volume of fine aggregate? 1 minus total 100% means 1 minus 0.63 means we get the value of 0.37. This is our volume of fine aggregate content. Okay. These are all the stepwise data from estimation of volume of aggregate proportion is coarse aggregate proportion is 0.63 and fine aggregate proportion is 0.37. Okay. Next we are going to be calculating number 6, which is estimation of mixed ingredients. Okay, mixed ingredient means first A, volume of aggregate. Total volume of aggregate we are going to be calculating. This calculation means we are going to be calculate for ingredients for 1 meter cube concrete alone. Okay, so we have to consider how many meter cube of concrete are required. Okay, from this we are going to be consider here is a 1 meter cube of concrete. Okay, so based upon this we have to assume volume of entrapped air in a wet concrete. There is a air in our concrete, wet concrete. So we assumed 0.01. That is a 0.01 meter cube is a volume of entrapped air available in 1 meter cube of concrete. Next one is C, volume of cement. How we can get the volume of cement means there is a formula, mass of cement divided by specific gravity into 1 divided by 1000. We already know the mass of cement is 355 kg and also specific gravity is 3.14. Okay, and get into 1 divided by 1000. This is the formula. So we get the volume of cement is 0.113. Okay. Next, similarly, volume of water. The formula is same. Mass of water into divided by specific gravity into 1 divided by 1000. Okay. Mass of water we already calculated, which is 159.7 kg divided by specific gravity of water is 1. We already know. Okay. So we get the value of 0.159. This is the volume of water. Next, volume of total aggregate. Okay, how we can get the volume of total aggregate means 1 minus, which is 1 is a 1 meter cube concrete minus 1 minus B plus C plus D. Okay, what is the value of B? It is a 0.01 meter cube. What is the value of C? 0.113 meter cube. What is the value of D? It is a 0.159. So we can get the final value of volume of total aggregate. Volume of total aggregate 0.713 meter cube. Okay, in the total 1 meter cube concrete, the total aggregate volume of total volume of aggregate is alone is 0.718. Remaining are the cement, water, and entrapped air. Okay. Next one is we are going to calculate the mass of aggregate. Okay, how we can get the mass of aggregate means mass of coarse aggregate means there is a volume of all aggregates into volume of coarse aggregate and specific gravity of coarse aggregate into 1000. Okay, so this is the volume of total aggregate. So we can get the value of 0.718 into 0.63 from here. Volume of coarse aggregate is 0.63. So 0.63 and at the beginning itself we can consider the specific gravity of coarse aggregate 2.62 into 1000. We get the value of mass of coarse aggregate is 1185.1 kg per meter cube. Okay, this is the mass of coarse aggregate. Next, we are going to be calculate the mass of fine aggregate. Okay, mass of fine aggregate, the formula is same. Volume of all aggregate into volume of fine aggregate into specific gravity of fine aggregate into 1000. Okay. Here, volume of all aggregate is 0.718 and volume of fine aggregate is 0.37. Here, the volume of fine aggregate is 0.37 and specific of fine aggregate from beginning, it is a 2.72 into 1000. We get the value of volume, mass of fine aggregate is 722.60 kg per meter cube. Okay, this is our summary of mixed ingredient. Here, the cement is a as per calculation, we get the cement value of 355 kg per meter cube and the water of 159.7 kg per meter cube and fine aggregate 722.60 kg per meter cube and coarse aggregate is volume of coarse aggregate is mass of coarse aggregate 1185.10 kg per meter cube. The admixture is we are going to be using 1% of cement value. So the cement is a 355 kg per meter cube. So as per thumb rule, we are going to be consider 1% as a admixture. So the admixture value is 3.55 kg per meter cube and the water cement ratio is 0.45. These are all the summary of our calculations. Okay, so based upon this summary, okay, we can get the mixed proportion of 1 is to 2.03 is to 3.33. One is a cement. So 1% cement and 2.03% of fine aggregate and 3.33% of coarse aggregate. This is a summary of our mixed ingredients and mixed proportions. Thank you.